Hey everyone, and welcome to the Tom's Hardware Podcast for April 27th, 2021. As always, I'm Tom's Hardware Editor-in-Chief Avram, and I'm joined by Associate Editor Les Pounder and Raspberry Pi expert Ash Puckett. And today's special guest is engineer Katie Dumont. Hi Katie, how are you doing?
Hi, yeah, I'm great, thanks.
Thank you so much. Thank you so much for joining us. I know you've got a couple of really amazing projects that you can show our audience in a couple minutes. But why don't you tell everyone about yourself and how you got started with Pi?
So I'm Katie. I live in Cornwall in the UK. Off tip, and I've been into electronics for years. I did electronic engineering at uni and stuff, and then general making, worked making road signs for a few years, and then I've had like a maternity leave with my children for about 6 years, so I've started making things that come into my head again. And tinkering.
That's great. Are your kids old enough yet to get involved in your projects?
The youngest is 3, so not so much, but the eldest is just 6, and he's just started doing some microbit stuff.
That's great. That's great. I always feel like doing electronics is a family affair. My son, who's 9, and I have been doing projects together for 3-4 years now. And last week we had some guests on. That was a whole family of makers, where the oldest one is 14 and the youngest one was 8. So it seems that the kids can pick this stuff up. So we asked this of all of our guests. How many Raspberry Pis do you have?
On the spot. I'm trying to think now. Probably a dozen maybe, and then I've got 3 or 4. I run a code club in the local primary school, so the club has 3, I think, that are all in my desk box as well for the school.
We should count those too.
Yeah. That's really cool. You just can't have one.
I don't think we've ever met anybody with just one.
Yeah, that would be, well, they wouldn't come on our show, right? So that very true. I think we're all up in the dozens now. Les is like 50 of them or something.
Especially not to have the Pico.
Yes.
My husband has quite a lot as well.
So in your whole house, how many would it be?
I was going to say, even like my 6-year-old's got one of his own because he started playing Minecraft on it. So we're like, here's Raspberry Pi.
Yeah, I guess I count the ones that my son uses as my Raspberry Pis because they just keep going around. You know, he'll come in and start using something, and I don't know, it just goes from there. So you managed to make a really awesome keypad project. Can you tell us about that?
So this is my keypad project, which is based on a Pico.
Oh, that looks so sleek.
So
awesome.
The pictures don't do it justice. When you hold it up and move it, that looks really, really well finished.
Yeah, that's beautiful.
I gave myself a bit of a 3D printing challenge.
What gave you the idea to make this?
So it was on my to-do list quite a few years ago. Back when I was working before kids and doing PCB design and stuff for work, and I always thought it would be really handy to have all the shortcuts mapped. But I never got round to it. And then, the last 12 months now since I've started doing more again in PCB design, I suddenly realised that I was missing it. It's to help me. So you can scroll through, but there's KiCad and all the shortcuts needed.
So the screen, can you explain how it works?
Yep, so it's the 4D system screen, which you can send serial commands to. So that's, plugged into one of the UARTs on the Pico, and then that sends all the lines and what text you want in what positions across to the screen. And so the top line is the program that the shortcuts are currently set for, and then a grid of what each shortcut is. And they're picked up. You can drag a text file which lists all the shortcuts onto the Pico when it's connected to the computer, and it will generate it from there.
Wow, fantastic.
That's
So,
cool.
so how many keys are there?
12.
Wow. So how did you wire 12 keys to the Pico? Does each one have its own GPIO pin?
Yes, yeah. I was going to say, I could open it up. I made a case, it all sort of slots together.
Oh, that's even better.
The case is 3D printed?
Yeah.
Oh, it's beautiful 3D printing. That's really nice.
And what kind of switches are those keys using again?
They're the Cherry MX
Ah, that's good.
black ones. So that's
Nice.
what we've got.
Ooh.
Wow. So so all the wires go directly. Is there a custom PCB or that's just the only other board in there is the screen?
No, yeah, so it's directly onto the Pico. The only board we've got, which side is it? Is the screen and the controller for the screen.
Oh wow.
Very
Neat.
nice.
Yeah.
So is that a TFT screen,
That's-
Katie?
That is really cool. So what did you program it in? How did you code it?
So I've done it in CircuitPython. I tend to be more happy in C, but when I tried to do it in that, trying to think now, the HID libraries weren't human interface device libraries, didn't seem quite set up yet, and they were on CircuitPython. So it's the first thing I've ever done with CircuitPython. But
Nicely done.
Yeah, it's really good for, as we've seen before, it's really good for creating a HID, creating a human interface device. I mean, we've seen that there are several other products out there where you can do that, but none as nice as yours. Like we have, I'm trying to see, I have one over here. This is, I have to actually show it. This is the keypad from Pimoroni. Les has shown the new Keybow RP2040, but I like your. But with all due respect to our friends at Pimoroni, I like yours better because it has a screen, and it's all spaced out, which is really nice.
It's
So-
all the functions on the fly as well, so you can change applications with the rotary encoder. That's what gets me. It turns it from just like a 12-button keypad into as many as you want.
yeah.
That's very cool.
So I get it plugged in again. So even things like I wanted more, so I've got KiCad schematic editor and KiCad PCB layout as two separate sets, so I can have 12 on each, or you could have 2 parts.
Wow. Fantastic. So did you find there was anything that you couldn't that you wanted to do with it that you couldn't do with CircuitPython? Was there any type of macro or something that you still can't do with it?
So I've got the rotary encoder on there. When I was programming it up, the actual rotary side of it wasn't working yet in the version of CircuitPython I was using. So I ended up doing it as the push function on the rotary encoder instead of rotation. But last week, I think I checked, and that's been fixed now. So there is the library, but it's been my son's birthday this week, so I haven't actually gone back in and
Aw.
I
That's
commented out the lines for the rotary encoder, so I need to go back out and uncomment them and see if it's working.
That's really fantastic. Oh, we have a comment here. Russell says the case is really nice and shiny for 3D printed case. It almost looks laser cut. Yeah, I agree. What kind of 3D printer did you use for that?
So our 3D printer, people I know call it a bit ancient, in a loving way. So I was at the University of Bath at uni, which is where the RepRap was developed as a university project. So my husband was doing PhD and was in the office next to Adrian Bowyer's. So he popped to the door next door and get us a 3D printed parts. And that's still the RepRap we're using with a few modifications.
Great.
So to get the shiny side, that's the bottom layer is always the shiniest. So you had to orient those before you printed them so that all the outside layers were on the bottom to get that shiny, right?
Yeah.
So that's how that works.
So the bottom's shiny, the edges are not quite so shiny.
Yeah, it's just beautiful, and it completely snaps together too.
Yeah, I like giving myself difficult challenges.
What did you use? What software did you use to design it?
So I used OpenSCAD.
Wow.
Yeah.
So Russell also says, years ago there used to be a really expensive full-size keyboard where the keys were tiny OLED screens. This is as nice. Yes, I'm familiar with that keyboard as well. Well, I'm familiar with a keyboard that did that. Maybe there was more than one. There was one from Art Lebedev Studios. I remember seeing it at CES show many times, and the keyboard was like $800. Well, depending on which one you got. If you got the full one, it was like $800 to $1,000, and if you got like the little keypad, it was like $300 or $400. Very, very cute, but not very practical because the keys were not mechanical keys, so they weren't exactly like a great typing experience. And if you're really a touch typist, would you be looking down at the keys anyway? So I think your way of doing it is the way. Like, show a screen to show what each key does, and then let the keys be really good quality mechanical keys. How did you mount the switches so that they stay there?
So they're just clipped into the frame. The Cherry MX keys have got their own like little clip, so they just pop in and out from the bottom.
Neat.
Wow.
Nice.
That is slick.
That is really slick. It looks like a good typing experience. Have you thought about doing a complete QWERTY keyboard?
No, I haven't. That could be quite cool. I've just recently bought myself quite a nice new keyboard, which is like the best keyboard I've ever owned. So,
Really? Which one?
the MX keys.
Ah, very nice. Very nice.
Because I got fed up of typing on a slightly meh one.
Yeah, no doubt. I mean, artists need their tools, right? You have to have a good keyboard. Absolutely. I can't live without mine. So you also have recently created something else that's really cool, a camera that looks like a toy but totally isn't. Can you show us that?
Yep. This is one of the first sort of projects I did getting back into it. So
It's so
I
cute.
was trying to think of something that I could use when the new high quality camera came out. And I was trying to think. And then my son got a Lego set. He quite likes the Lego Friends sometimes. And they did a set with like an item from each of the 5 Lego Friends. So one of theirs was a camera. So it was a kit to make a Lego not functioning camera. And I was suddenly like, oh, I wonder. So I didn't ruin his. I did buy myself another set. So I needed to add, I think, about a layer and a half. So I think there's 2 tile thickness added to the bottom and 1 brick at the top from the original model, but the width and everything is still the original. yeah, and then I stuck all the Lego bricks together with Mech, which is what they use for Lego, like Legoland and stuff, and glued it all together, dremeled out a hole for the lens, and then it's got an LCD on the back.
Oh wow!
So with
That's cool.
When you say with Mech, what is that?
Methyl ethyl ketone, I think it is. It's a chemical that dissolves Lego, like it melts Lego together.
Wow.
I bought some years ago for making a keyring out of Lego, and the internet seemed to suggest it was the best thing to buy. And I think you can like drop a Lego brick into some of it, and if you get the consistency right, you end up with molten Lego that you can reform into stuff.
That's wild.
But they were doing a program recently where it was like behind the scenes at Legoland, and they had bottles with Mech written on it. So I was like, I've got the right stuff.
Oh wow! That's like that's a learning experience for me. I thought that went against like the morals of Lego or something to glue your Lego together. I mean, isn't that what Mr. Business did in the Lego movie? I mean, not supposed to do that, right?
Yeah, I wouldn't usually ever do it, but I didn't really want to drop the camera and end up picking up 200 bricks or whatever off the floor.
Yeah,
so,
I totally understand that. So what type of Pi is in there?
Right, so inside I've got a 3. So it all comes apart. Even though I glued it together, I glued it into sections.
Very smart.
So you can still take it apart. I think it breaks into 6 sections.
That really is key when you're working with microelectronics. You need to get in and fiddle with it.
Yeah. And it's got like a power button. I drilled a little hole with a Dremel and stuck a switch.
Did you have any trouble dremeling, not just through that for the power there, but for the lens in the front?
It's fairly easy, but it sort of makes a lot of plasticky strands that are burning hot, so if they touch you, they're a bit molten.
Oh, fun.
So, yeah. But no, it was fairly easy. So, yeah, it's got a little B+. I couldn't, A+, even. I couldn't fit a full-size one in.
Oh.
But I thought a 0 probably wouldn't have quite enough power for doing the processing of the image to the LCD.
That makes sense.
Is your battery rechargeable too?
It is. It doesn't recharge. I've got lots of bits now in the camera, but it's just a little LiPo.
You can just pop it in and out. Nice.
Yeah, open up the side section.
Wow, that is really impressive. That is the only point and shoot that I would want to use. Russell asks, is that the dark one? Is that dark one just blue or in bad light?
Is the camera purple or dark blue? I think he's what he's getting at.
Yes.
Oh, it's purple.
It is indeed purple.
Yeah.
There you go, Russ. You're right. Purple and lavender are the best colours. Yeah.
Yes. In fact, later in the show, I will show you another purple. This is a purple show. We will show you another piece of purple electronics. So that is really, really cool. So I really like how you use the screen on that. Les, you've been doing some things with an OLED screen lately. Can you show us what that's all about?
Yeah, definitely. So recently I updated a guide to using OLED screens with the Raspberry Pi Pico. So there's a tiny little screen that you can get, usually 128 by 64 pixels in size. There's nothing to them, but they're really easy to work with thanks to a lot of great libraries. So I've been messing around with a library called SSD1306, a memorable name, but that's basically the name of these OLED screens. And I've got it doing some pretty cool things, even if I say so myself. So on the left is the screen, and you can see right now it's doing squares, just random rectangles. Now we've got text, a grid. These are all being written on the fly by a Qt Pi from Adafruit here, Qt Pi RP2040. and it's connected via the Stemma QT connection directly onto this board. And I've got bitmap graphics. That's a 1-bit bitmap graphic of the Tom's Hardware hammer. There's our logo. And as I say, this has all been made on the fly, and I can quickly show you the code now. So the code is quite a lot of code, but I'm going to break it down and just explain quickly what it all does. So like any Python program we've got our imports at the start that explain what libraries we're using. So I want to use the GPIO, so I import the pin and I2C classes from machine. Then I import the library for working with the screen. UTime is there to control the pace of the program. Random, because I'm going to use some random numbers later on. And frame buffer is used to draw images to the screen. So I set up an object called I2C. I tell it which I2C pins I'm using, in this case 22 and 23. I then say how big the screen is. And then I go into the main body of text. So I say, okay, let's draw some text onto the screen. I clear the screen. I then use show to update the screen. And then I've got the Tom's Hardware and the PyCast text there twice. And again, sorry, 3 times. And these are all slightly offset and different colors. The colors are controlled by 1 and 0. 0 being off, 1 being on. I then show that to the screen, and we see the Tom's Hardware logo like a staggered effect to it, like a drop shadow almost. We wait 2 seconds, we clear the screen, we update the screen. Then I use a for loop, 2 for loops in fact, one with a range of 8 and one with a range of 16, to draw those grids across the screen. 8 across and 16 down, I think it is, or is it the way around? 16 across and 8 down, that's it. Wait 3 seconds, clear the screen, show it, and then I do some random pixels like a star field effect. Wait for a second, clear the screen, then I start drawing some lines. These are slanted lines, almost like the hazard tape you can see. But then it gets a bit more interesting. And this is where we use an extra piece of software. So Don Hui, who writes for Tom's Hardware, Nova Spirit Tech on YouTube, he has an application which will strip images down to byte arrays. And here we have a byte array, which is the Tom's Hardware hammer. And it's really long, it goes off the screen. I then write that to the screen as a black and white image, mono, and then blit the image to the screen using a for loop to make it appear as if it's moving across. And you just saw the hammer go across the screen then. I then do the same thing with the Tom's Hardware logo. That's here, and blit it across the screen. And then at the end, we have these random squares, or random rectangles, I should say. So I just say to the code, look at some random numbers between 0 and 128 and 0 and 64. Set the size to be a random number between 0 and 20, and then draw those rectangles at the random coordinates with the random size. And it all appears on the screen. And that's it. This library is really cool to work with, really simple to work with. And yeah, I've enjoyed myself. It's almost like I've been making a demo from the 1980s on this.
Yeah, it's great.
Now, bear with 1 second, everyone. Sorry, my Bluetooth headphones are disconnected, so I can't hear what anyone's saying. Live demo.
So, I mean, I've been messing with that too. It's really a lot of fun. These SSD 1306 screens are only like $6-7, maybe less, if you get them in a bunch. Our friends at Gurgle Apps have some fantastic tutorials on working with the SSD 1306 and creating a ping pong game with it, which I just had to get some new potentiometers so my son and I can try the ping pong. It's really great what you can do with them. Can you hear us yet, Les?
Yeah, I can hear you.
I have a quick question for you. Why, if it's monochrome, why would you want to have a color set to 0 rather than just not draw whatever it is?
It's the parameters for that command. If you don't set that parameter, it'll just error. That's as simple as that. You have to tell it what it's drawing to the screen. Is it a 0? So is it black? or is it 1? Is it white? If that is omitted from the end, it will probably default to 0, but more than likely it will just error.
Right. So, so Ash, speaking of drawing things, you've come up with a really interesting new project.
Yes, I decided to create something that should be useful for anybody working from home. There's a train passing by outside. If you hear that, just ignore that. So, I wanted to create something that would make it easier to manage my schedule while I'm working from home. So, I decided to use my RGB Matrix. This is a really versatile project. It should be useful for kids. I mean, anybody who's at home who needs to keep track of a schedule, I guess, because it's not something you can quite take with you. You do need to keep it plugged in. So what I'm going to do first is adjust the screen so you can see the code that I used to make it work. And I'm going to demo this in real time, but that involves saving this code and then running it. So right now it's about 2:56 p.m. I'm going to set it for 2:57 and 2:58. And when that time hits, run it here. Running right now. Whenever, oops, no, it's not. It's running now. Whenever it hits 2:57, it will be Pi time. And if you don't believe me, check the matrix. It'll say Pi time. And a minute later, it'll change to another image. So I think the one thing that it's missing, or that you could use to expand on it, would be like a web portal, because the only way to program it right now is to go into the code and manually set the time. So I can give a quick overview if you'd like to see how the code works.
Yes, of course.
So first, I've got to import a couple of critical libraries that it uses. I'm using the Adafruit Matrix bonnet, so I had to import some of those tools to make the matrix work. There we go. It's Pi time right now. And there are a few options to tell it how big the matrix is, and that specify that, yes, I am in fact using the hat. I've got a function here that will check the current time, and another function that will display an image. And so I've got a loop going down here that if the current time is as specified, to set the image to whatever image I want. So here we have PiTime.ppm, and in just a minute, it's going to be nap time. So it waits about a minute before checking again so that it doesn't keep spamming the image. That would just kind of bog things down cache-wise. But that's how it works. And you can make any image you want to change. So I have it set to check about every minute, but I'm sorry, I have it set to check based on the hour in minute. But if you wanted to specify down to seconds, nap time, sorry. But you can specify it outside of that. But my code is just set to check for the hour in minute. So what do you guys think? Could you use something like this? Like, would you use that in your house?
Yes, I would make an alarm clock for my son. Is what I would do. I would have a I would also use a speaker. Now we've just seen two different types of screens that folks use, an LED matrix and a small OLED screen. Katie, what type of screen are you using on your keypad?
So the keypad is this is 4D Systems LCD. So they come. You can like program it up. I think you can program on the screen itself, or you can use this board that just gives you a serial interface to it.
Very, very cool. So since everyone is doing their projects today, I thought I would show really quick a project that I've been working on in progress. It's not as final as these folks, but this here is, my son and I call this Purple Bot, because we bought a purple robot chassis from Adafruit. This chassis actually is almost identical to the one that he has on his MBot. If anyone has bought one of those MBots, but it's purple, and he likes that. And of course, we like the fact that it's metal, because there's a lot of robot chassis you buy are plastic or acrylic and fall apart easily. So we got this because it's metal, And we got two TT motors, which are standard DC motors, and a couple of wheels, and attached them. And then we took, the biggest challenge is how do we power it? For powering Raspberry Pi robots, there seems to be like a couple of options. One is if you have a board like the Pimoroni Explorer hat, you could use a USB power source. But there aren't many USB batteries that are very small. And any other motor driver system that you use is going to want to have its own power source, meaning that you're going to need to have two different batteries on your robot, which is quite space consuming. Another thing that folks use as a battery is they use LiPo or 18650 batteries, but we wanted to use like really straightforward AA's. So you have to get a hat that is going to both drive your motors and convert the power to be used on the Raspberry Pi. And there's only a couple boards that do this. And the one that I have here, though upside down because it's facing down, this is how it faces, is the Thunderborg by PiPowered. And they don't sell it in the US. You have to send away for it from the UK. So if you are not in the UK, you'll have to, Pimoroni has it and PiPowered.com has it. And the way it works is it's all it's all screw terminals. So you have positive, negative for the two motors, and then for the power input, and it can convert, I think, up to 25 or 35 volts down to what the Raspberry Pi needs to power itself, and you need to power the motors. There's a very simple Python library for getting it to work, and it has a nice little RGB light on it if you want to use that. So all we really had to do was attach that and then figure out how are we going to make our batteries stay. So sort of imperfectly, we're using a hook and loop, otherwise called by some folks Velcro connection here, where you have a couple of bands around the battery case, and it also sticks to a sticker here. And every time I want to change the batteries, we have to take this out. So it's a little bit of an annoyance, but otherwise this is working in pretty good shape. Our next move is to mount a camera on the front of it, which we'll have to get a mount to put here, and then maybe a couple of sensors, and see how that goes. But I think my number one takeaway from this is how a lot of the motor driver boards that you can get for Raspberry Pi, including the ones from Adafruit and some other places, really require their own power supply separate from the Pi, which means that you're going to have multiple different power sources on your robot, which is really space consuming and annoying. So really kudos to the folks at PiPowered for making something that does what people really need, which is power both the Pi and the motors from one source. Anyway, that's all the time we have this week. But I want to thank everyone for listening and watching. As always, you can find us on YouTube and Facebook after the fact, or we are live 2:30 p.m. Eastern, 7:30 p.m. UK time every Tuesday. Thank you so much to Katie Dumont for joining us this week, and we will see you all next week. Bye, everyone.